Hello everyone, this is Rajari Chanjarla. I'm an educator at Unacademy. You can follow me on Unacademy Learning app where you can find my other courses as well. This lesson is about the method to calculate the probability of survival of rolling contact bearings which have the value more than 90%. And please rate, review and share the video and also subscribe to Unacademy YouTube channel.
Welcome again to bearings with more probability of survival. Before going to find the probability of survival of the rolling bearings, we have to find the life of the bearing, right? So the life of the bearing is defined by rating life. The rating life of a group of apparently identical ball bearings is defined as the number of revolutions that 90% of the bearings will complete or exceed before the first evidence of fatigue crack. Okay, suppose if we have 10 number of ball bearings in a group, okay, if 9 member of ball bearings exceed certain number of revolutions or the life before the first evidence of fatigue crack is seen. So the number of revolutions for the 90% of ball bearings is called as the rating life of the ball bearings, okay, and it is also called as the minimum life denoted by L10 or the catalog life denoted by B10, okay, and the reliability which defines the probability of survival of the ball bearings is defined as R equals to number of bearings which have successfully completed L million revolutions by the total number of bearings under test. So if we took n number of bearings for our test, if L number of if some certain number of bearings have successfully completed L million revolutions, therefore the value of the number of bearings which have successfully completed those L million revolutions by the number of bearings that we took for the test gives us the reliability R. Okay, so therefore the reliability of bearings selected from the manufacturer catalog is 0.9 or 90% because for the value of number of bearings which have successfully completed L million of revolutions from the rating life we have 90, right? 90 bearings for 100 bearings that we took, right? That's why we have the R value will be 90 by 100. Therefore the value of the reliability for the from the manufacturer catalog or the manufacturer catalog will be defined by rating life. That's why we have the value of R for manufacturer catalog equals to 0.9 or 90%. Okay, so with the help of these rating life and the reliability, we are going to define the probability of survival of the ball bearings. In certain applications where there is risk to human life, it becomes necessary to select bearings having a reliability more than 90%, right? So if we more concerned about the human risk of human life, we have to go for the bearings. We have to go for the selection of the bearings which have reliability more than 90%. Then only the safety of the humans will be there. Okay. So figure shows the distribution of bearing failures. So see in this plot you can find the life of bearings versus the percentage of bearings in a service. So this plot is for the bearings which were failed for a certain value of life, okay, for a certain value of revolutions. Here you can see for 90% we have the life L10 which is the rating life, right? So for the 90% of bearings, percentage of bearings, we have the life L10 which is the rating life. For the 50% of the bearings we have L50 which is the life corresponding to the median, the 50% of the bearings present in that group of the bearings that we took for the test, and they have exceeded the certain number of revolutions before the fatigue crack will be seen in those bearings. Okay, so this is the median life and this is the rating life, and this is the curve for the failure of the bearings. Okay, so the relation between the bearing life and the reliability is given by a statistical curve known as the Weibull distribution. So this is the Weibull distributions which gives us the relation between bearing life and the reliability. So from Weibulls distribution we have the relation between the reliability and the life of the bearings is given by R equals to E to the power of minus L by A to the power of B. Okay, so this is the relation which is the equation of this curve. Okay, so where R is the reliability in fraction and L is the corresponding life and A and B are the constants. So rearranging the above expression, we have got 1 by r equals to e to the power of L by a to the power of b, right? On applying log on both sides, we have got log e 1 by r equals to L by a to the power of b. So this is the relation between the reliability of the life and of the bearing, and also this is the equation of the curve in the Weibull distribution. Okay, so this is the relation, and if L10 is the life corresponding to reliability of 90%, that will be given in the manufacturer catalog will be 90%, or it is denoted by R10. On substituting this value in this equation, we get log e 1 by R90, that is equals to L10 by a to the power of b, because L10 is corresponding to R90. So in this figure you can see L10 is corresponding to R90, right? That's why we have replaced the value of R with R10, R90, and L with L10. So dividing these two equations, we have the relation L by L0 equals to L10 equals to log e 1 by R by log e 1 by R90 to the power of 1 by b, where R90 equals to 0.9 and the values of a and b are a equals to 6.84 and b equals to 1.17, and these values are obtained from the condition L50 equals to 5 times of the L10. Okay, where L50 is the median life, or life at which 50% of the bearings will complete or exceed before the fatigue failure will be seen in those bearings. Okay, and the above equation is used for selecting the bearings when the reliability is other than 90%. So with the help of this relation, we can find the reliability of the bearings, or the life of the bearings which has the reliability more than 90%. Okay, so here we have in a system, if there are a number of bearings, then individual reliability of each bearing should be fairly high, right? If there are n bearings in the system, each having the same reliability R, then the reliability of the complete system is given by Rs equals to R to the power of n. Okay, so we can find the reliability of the complete system given by this relation, and which is also equals to the probability of survival of the bearings in that complete system. Okay, where Rs indicates the probability of 1 out of n bearings failing during its lifetime. Okay, so this relation is very important, and this relation is used to find the life of the bearing which has the reliability other than 90%. Okay, and L10 and R10 values are corresponding to the rating life, and A and B values are given here. A equals to 6.84 and B equals to 1.17, and the relation between L50, which is the life of the bearings corresponding to the 50% of the bearings will have before the fatigue life will be seen in those bearings. Okay, so the value of R90 is given by 0.9 here. This is 0.9, and so with the help of this relation we can find the life of the bearings which has more than 90%, and it is, and until now we have seen the reliability of 0.9 only, which is corresponding to the rating life, right? So this equation is for the life other than 90%. Thank you.